Welcome to the video for C2.2.2. So we're going to look at electronic structure in this lesson. So previous knowledge, we're going to go over this a little bit, but you already know from previous lessons that atoms are made from protons, neutrons, and electrons. We know that the protons and neutrons are in the nucleus, and then the electrons are found in shells around the nucleus. And you should also know that the number of electrons an atom has is equal to its atomic number, but we're going to go over this on the first few slides anyway. So our learning objectives for today are we need to be able to describe the electronic structure of the first 20 elements. And you need to be able to explain how the position of an element in the periodic table relates to its electronic structure. So first of all, a bit of revision. So what an atom looks like. So if I could have a microscope that could zoom in and could look at what an atom exactly is, we would see this core in the middle, which is a nucleus, which has the protons, which are positively charged, and the neutrons, which have no charge. And then a lot of empty space, and the electrons, which are negatively charged, in shells around, which kind of orbit the nucleus. So if we look in the periodic table, we will see two numbers. We'll see an atomic number and we'll see a mass number. And the mass number, apart from hydrogen where they're the same, will always be bigger than the atomic number. And these two numbers tell us the number of electrons, the number of protons, and the number of neutrons when we use them together. So the atomic number tells us the number of electrons. So that's the one that we're going to use today. But also, while we're here, we may as well revise the fact that the atomic number also equals to the number of protons. And if I want to find the number of neutrons, it's the mass number minus the atomic number. So for an example, if I had aluminium, if you look in the periodic table, its mass number is 27, its atomic number is 13. So it's going to have 13 electrons, it's going to have 13 protons, and then the number of neutrons is the difference between the two numbers. So that's 27 minus 13, so that's going to be 14. So as it says there, aluminium is going to have 13 protons, 13 electrons, 14 neutrons. So we need to look at electrons in more detail. That's what today's lesson is about. So you need to know the rules for electrons. So first of all, we already know that electrons occupy shells or orbits around the nucleus. But what we've not discussed before is that there's more than one shell. And the first shell, so when we say the first shell, we mean going from the nucleus outwards. So the first shell, if you start in the nucleus and you travel outwards, the first shell can only hold 2 electrons. And then the second and third shell can hold up to 8 electrons each. And importantly, the electrons always fill the shell closest to the nucleus first. So they'll fill the first shell first, then they'll go to the second, and they'll go to the third. Now, this is a bit of a simplification. When you get to A level, you realise the second and third shells don't actually hold 8 electrons, but we'll worry about that when we get to A level. So I want to do an example here, but it's difficult to do it on the board. So what I'm going to do is make another video where we practice drawing electronic structures, where I'm going to draw some out and show you some examples of different elements. So I want you to pause this video now, go and watch that other video, and then come back and watch the rest of this one. Okay, so hopefully you've watched the video and you've done some practice of drawing electronic structures. So now what I want you to do is for the first 20 elements, so starting with hydrogen, then helium, the first 20 elements, you need to write down the name, the chemical symbol, and then the drawing of the electron configuration, the shorthand for the electronic configuration for the first 20 elements. So in your exam, you could be asked to do this for any of the first 20 elements. Okay, and if you feel like it, there's an extension task, which is to just have a look at the ones that you've drawn. So if you have a look at the electron configurations you've drawn, if you pick 2, they've got in the same group. So you could pick lithium and sodium, for example. I want you to have a look at the electron configuration and see what similarity there is. And then the same for the period. So pick 2 or 3 elements in the same period and then look at what relationship there is between that and the electronic structure. Okay, and then pause the video before you go into the next slide. Okay, so this answers your extension question. So the group number for an element is the same as the number of electrons in the outer shell. So although this was an extension question, you do need to know this even if you didn't have a go at the extension question. So elements with electronic structures of 2, 1, 2, 81, and 2, 8, 8, 1 would all be in group 1 because they all end in 1. So that last outer shell has 1 electron, so they're in group 1. So if I was to look at group 2, they'd all end in 2. Group 3 would all end in group 3, etc. So for the period number, it's the same as the number of occupied shells. So for example, if you've got these 3 elements with the electronic structures of 2, 1, 2, 2, 2, 8, then they're all going to be in period 2 because it's the number of occupied shells is the number of numbers. Or if you see it drawn out, the number of shells that have got electrons or crosses drawn in them. Okay, so your second task is to have a go at this exam question. So I want you to pause the video, have a go at that exam question, and then the answer's on the next slide so you can check your answer. Okay, so it asked you to choose 2 in the same group. So you wanted 2 that had the same number of electrons in the outer shell. Although helium's a bit more complicated than that, so I'll get back onto that in a minute. So magnesium and calcium, if you look at their electronic structure, they're both end in 2, so they're both in group 2. Now, helium's a bit more tricky because if you, the final group on the right-hand side all has a full outer shell. So helium, even though it doesn't have 8 electrons, it's got a full outer shell. So helium and neon both got a full outer shell, and therefore they're in the same group as each other. Right, task 3 is a second exam question. This one's worth 4 marks. You need to make 4 points. So it says particle C has got the electronic structure 287. What does this tell you about the position of particle C in the periodic table? Explain your answer. So you need to, by position, it means what group is it in and what period it's in. So you need to say which group it's in, which period it's in, and then explain for each of those why you know that. So pause the video. The answer is going to be on the next slide. Okay, so the answer was, in terms of group, that it's group 7, and that's because there's 7 electrons in the outer shell. And that it was period 3 because there's 3 shells occupied. And we know there's 3 shells occupied because when you see the electronic structure written out like that, it's got 3 different numbers. Okay, thank you for listening. See you next time.